So we're going to be looking at section 1.3 rates of change. So here we're going to be looking at the dependent variable and the independent variable. So in an equation like this, the y is the dependent variable and the x variable is the independent variable. So the dependent variable y can represent quantities such as volume, air, temperature, area. The independent variable x can represent quantities such as height, elevation, and length. So we'll be looking at relationships. For example, the volume of a balloon varies with its height above the ground. So the volume is the dependent variable and the independent variable is the height above the ground. Or the air temperature varies with elevation. So the y variable is air temperature and the x variable is the elevation. See, the surface area of a sphere varies with the length of the radius. So the independent variable is the length of the radius and the dependent variable is the surface area of the sphere. So in this section, we're going to be looking at average velocity and instantaneous velocity. So when you're given 2 points, you're more likely going to be using the formula average velocity, which is change in position and change in time. So change in position and change in time, you usually have a final position, an initial position, and a final time and an initial time. So and for instantaneous velocity, what you're going to do is you're usually given a single point. So like, what is the velocity at time equals 3 seconds? Since you're not given 2 time points, you know this question is asking for instantaneous velocity. And in this case, you're supposed to find the limit of the function like how we did in the previous section. So you're going to find the limit as t approaches 0 for the change in distance over the change in time. So we'll be just finding the limit, which was exactly the same as what we did in the last section. So we'll look at an example where we have to do average velocity. So here a a pebble is dropped from a cliff 80 meters high. After t seconds, the pebble is s meters above the ground, where s at t is equal to 80 minus 5t squared, where 0 is less than or equal to t and t is less than or equal to 4. So here, calculate the average velocity of a pebble between times t, 1 second, and 3 seconds. So if you see this gives you 2 points, so you know that you need to use the average velocity equation. So what you do is you take the t1 and you put it into the equation. So 80 minus 5 times 1 squared, you get 80 minus 5, which is 75. So that's what you get for 1. When you put the 3 into the equation, you get 3 squared, which is 9. 9 times 5 is 45. So 80 minus 45 is equal to 35. So you know that S3 is equal to 35. So now you put it into the equation, which is change in change in distance over change in time. So you have 35 minus 75 divided by 3 minus 1, which is 2. So you get negative 40 over 2, which is equal to negative 20 meters squared. So that's just one example of average velocity. Let's go and see instantaneous velocity example. So here they give you a toy rocket is launched straight up so that its height s in meters at time t in seconds is given by s at t is equal to negative 5t squared plus 30t plus 2. What is the velocity of the rocket at t4? So since they're only giving you one time point, you know that you need to find the instantaneous velocity, which is the limit of this equation. So when you put 4 into this equation, you get negative 5 times 4 squared plus 30 times 4 plus 2. So that is what they did in this, and they found that it was 42. So if you do, so now we're going to look how they're finding the limit as they're doing. Um, what you do is you take this equation, and wherever there's a t, you're going to put the t value plus h. So negative 5, 4 plus h squared plus 30 times 4 plus h plus 2. And then when you expand it out, you get this, and you get negative 5h squared minus 10h plus 42, and you have to subtract it from what you get in this. So you're just left with negative 5h squared minus 10h, and then you factor out the common, which is h, and you're left with negative 10 minus 5h. And then when you substitute 0 for h, you're left with negative 10. So you find that the instantaneous velocity is 10 meters downward at t equals 4 seconds. So let's jump into the questions. So here, the velocity of an object is given by as v t equals t bracket t minus 4 squared. At what time in seconds is the object at rest? So you have to find out when the velocity is 0, because that's when the object is at rest. So since this is already factored for you, you know that at t equals 0, because you have to find the since it's already factored for you, it's quite easy. So t minus 4 equals 0 and t equals 0. So you find that the object is at rest at t equals 4 seconds and t equals 0 seconds. So I'll just... So since the equation is t and t minus 4 squared, it's already factored for you. So you know that t minus 4 equals 0. So t equals 4 seconds and t equals 0 seconds. Okay, let's do the next question. Okay, give a geometrical interpretation of the following expression if S is a function, a position function. So here, what you would be doing is you would, when you find the slope between 2 points, you're finding the slope between the slope for a secant. If you're finding the limit of a single point, you're finding the tangent. You're finding that tangent for that point. So here you see that it's 2 points. So you're finding the secant. You're finding the slope of a secant between positions 9, between point 9 and point S8, or the distance at 9 and the distance at 2. And the change in time is equal to 7. So here you can tell that this is the point on which you want to find the instantaneous velocity, or the tangent, at position 6. So we are looking for the slope of the tangent at S6. So here, if you see this equation, what are we trying to find? So if you see whatever this has been, x is always substituted with the value of x plus h. So you know that inside of this function is an x. So, and since the value here is 2, you know that the answer for putting the x value in this is equal to 2. So we're trying to find the limit for the limit of square root x at S4. Let me just show you. So you have 4 plus h minus 2 over h. So what this is really is x. We're trying to find the limit of square root of x. And then how we get this 2 is that when we put in the value of 4 in this, you get 2. So here we're trying to find the limit of y equals square root of x at position 4. So here, use the graph to answer each of the questions. So let's go to here. Mm. So if you look at, we should look at all of the points and figure out the coordinates of each of those points, A, B, C, and D, and E. So if you look at it, you have A, which I believe is 2.5 and 1.5, and B is 3.2 and 3, C, which is equal to 5.1 and 3, D, which is 6 and 1.5, and E, which is about 9.9 and 1.5. So we need to find the slope between these points because they want us to find the between the two consecutive points. So we need to find the slope between B and A, C and B, D and C, and E and D. So let's do that. So the slope between B and A, and then the slope is between C and B, and then between D and C, and between E and D. So you have the formula, which is y2 minus y1 over x2 minus x1. So what is the points? So y is 2 is 3 minus 1.5 over 3.2 minus 2.5. You get 1.5 over 0.7, which is equal to 2.4. 2.4. Now let's do the same for here. So C and D. So the y is 3 minus 3 over 5.1 minus 3.2 equals 0 over 5.1. 1.8, and which is equal to 0. And then we have to find between D and C, which is 1.5 minus 3 over 6 minus 5.1, which is equal to negative 1.5 over 0.9 equals negative 1.66. And then we are going to do the ED, which is going to be 1.5 minus 1.5 over 9.9 minus 6, which is equal to 0 over it's going to be 0.9 3 by 9, which is equal to 0. And you can see which one has the highest value. Highest value is the slope. The magnitude of the slope between A and B is the highest. So slope between is greater. Is the average rate is the average rate is the average rate of change in function between A and B greater than or less than the instantaneous rate of change at B? So if you look at the if you look at B, if you were to do a tangent at this line, and if you look at the slope between A and B, the line is actually steeper. The secant between A and B is actually steeper than the tangent at B. So just visually, you can see that the slope is less steep than the secant between A and B. So slope of secant between A and B it's more steep than the tangent at B. Okay, and the next question. Sketch a tangent to the graph somewhere between points D and E such that the slope of the tangent is the same as the average rate of change in the function between B and C. So if you look here, B and C, we found B and C to have a slope of 0. So where on this graph would have a instantaneous sketch it, yeah, at which point would the tangent be have a slope of 0? Here, this point. So if I drew the curve here, the slope at this point is 0. and is equal to the slope between D and C, which was at these 2 points. The rate of change between those 2 points is equal to the tangent at this point, which is in between D and E. So let's look at what is wrong with the statement. The speed of the cheetah was 65 kilometers per hour north. Okay, so speed doesn't have a direction. Velocity has a direction. So we could say that the velocity of the cheetah was 65 kilometers per hour north, or the speed of the cheetah was 65 kilometers per hour. Okay. Let's say, look at this. Is there anything wrong with the statement? A school bus had a velocity of 60 kilometers per hour for the morning run, which is why it's running late. Which is why it was arriving late. So what's wrong with this? Like I said previously, um, velocity has to have a direction. Speed doesn't need a direction, but velocity requires a direction. So maybe we could say the school bus had a velocity of 60 kilometers per hour north or east or whatever direction it was traveling. So let's look at the next question, 7. So we're going to look at 7. So for question 7, we're going to look at the equation. A construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt has fallen a distance of s meters, where s at t is equal to 320 minus 5t squared, where t is between 0 and 8. So calculate the average velocity during the first, third, and 8th second. So we're going to look at this one as so if let's put in, so at s at 0, it equals 320 minus 50 squared equals 320. Let's find when it's 1. 320 minus 5, 1 squared, which is equal to 5. So 320 minus 5 is equal to 315. S at 2 equals 320 minus 5, 2 squared, which is 4, which is 320 minus 20, which is equal to 300. Let's do 3. S equals S at 3 is equal to 320 minus 5, 3 squared, which is equal to 320 minus 5 times 9, which is 40. 320 minus 40 is equal to 280. S at right? If I put 3, it is not, oh, this is 45, sorry. 320 minus 45 is 275. And you have S at 4 equals 320 minus 5, 4 squared, which is 16. 5 times 16, which is 80. So 320 minus 80 is equal to 240. And let's look at 5. 5 squared is 25. You have 320. 320 minus 125. It equals 195. Okay, so let's see if we found. So calculate between the first, third, and 8 seconds. Okay, so for the first second, we are gonna do the average velocity is equal to what did the first second? What is it at the first second? It's 315, and that's the first second. And then at the 0th second, it's 320. So it is -5 meters per second. I believe it's in meters per second, right? Meters per second, yeah. Okay, now it's asking for the third second. So we have to look at the third and the second. So this is for first. Okay, so average velocity at the third. So what is it at the third? It's 275 minus what it was at 2 seconds. This is 3, it's 2. You're left with 1, and you're left with 25 negative meters per second. And we should look at 8, AV8. So at 8, oh, is it asking for 8? 8th second. Oh, we have to continue and do. So ST 320 minus 5t squared. So let's find it for 7 and 8. 320 minus 5 times 7 squared. And then you have 320 minus 5 times 8 squared. Okay, so 320 minus 5 times 49 equals 5 times 49 is 320 minus 245 equals 75. Then we have 320 minus 5 times 64 equals 320 minus 5 times 64. 320 is equal to 0. So average velocity at 8 is equal to 0 minus 75 over 8 minus 7, which is negative 75 meters per second. So next question is, calculate the average velocity for the interval 3 and 8. So we should look at, oh yeah, we have to remember what it was at 3. So 320 minus 5, 3 squared, 5 times 9, 45. So 320 times 45 equals 2, I believe it was 275. Yeah. So we should find the change average between 8 and 3. So at 8 it was 0. At 3 it was 275. And it was 8 and 3. So you're left with 275 negative over 5, which is equal to negative 55 meters per second. So now calculate the velocity at 2. So now they only gave us 1 point. So what that means is find the instantaneous velocity, which is the limit. So let's find the limit. So 320 minus 5t squared, and it said to find it for 2. So when you substitute 2 into this equation, what do you get? Minus 5, 2 squared, 320 minus 5, 4. You're left with 320 minus 20, and you have 300. So, okay, let's do 320 minus 5, and then the t squared, you're going to substitute the x, which is 2 plus h squared minus 300. So 320 minus 5, and we can do this out, which would be h squared plus 4h plus 4 minus 300. So we have 320 minus 5h squared minus 20h minus 20 minus 300. You're left with negative 5h squared minus 20h over h. So substitute out, factor out the h, which would be negative 5h minus 20 over h. You're left with negative 5h minus 20. So when you substitute 0 for h, you're left with negative 20. So at t equals 4 seconds, the instantaneous velocity would be negative 20 meters per second squared. Let's look at, let's look at 8. Okay, let's, So the question is, the function s at t equals at times t plus 2 describes the distance s in kilometers that the car has traveled after a time t in hours for 0 is less than or equal to t and t is less than or equal to 5. Calculate the average velocity of the car during the following intervals. So from t equals 3 to t equals 4, t equals 3 to t equals 3.1, from t equals 3 to t equals 3.01. So now let's use the results from part A to approximate the instantaneous velocity at, okay, so let's do this. The function is s t equals 8t t plus 2. Whoops. It's okay. You guys can read it. So t equals 3 and t equals 4. So what we need to find is s at 3, which is equal to 8 times 3, and 3 plus 2, which is 24 times 5, which is equal to 120. And then s at 4 equals 8, 4, and 4 plus 2, which is equal to 32 times 6 equals 192. So we need to find the average velocity between these 2 points. So the average velocity between these points are, let's take this as point 2. You're left with 1, and here you're left with 72 meters per second. Okay, now let's find, that's just I. Now it's 2, 3 and 3 point, so now this one is for 3. So now we have to find for 3.1. So s at t, s at 3.1 equals 8, 3.1, 3.1 plus 2 equals 24.8 times 5.1 equals 126.48. So now you have to find the average velocity between these 2 points. So you have 126.48, or yeah, 126.48 minus 120 divided by, this is at 3.1 minus 3. So you're left with 0.1 and 6.48, which is equal to 64.8 meters per second. So we know at 3 it's 120. Now let's do the next one, which is 3.0. S at 3.01 equals 8, 3.01, and 3.01 plus 2 equals 126. Oh, no, sorry. It's 120. 6408. So now you know that S at 3 is equal to 120. So the average velocity between this point and 3.01.3 equals, you're left with 0.01, and the top is 0.6408, and you get 64.08 meters per second. So if you see this, it says use your results from part A to approximate the instantaneous velocity. So if you see, based on what we got from the previous answers and everything, as the value gets closer and closer to 3, the instantaneous velocity at 3 is close to 64. So I'm going to say be 64 meters per second squared. So now we should calculate the instantaneous velocity, which is done by finding the 8t plus 2. So what we can do is 8t squared plus 16t. So now at when we put 3 into the function, we know that the value is 120. So you have to do minus 120, and then now it's 3, right? So we're going to substitute the t's as 3 plus 8 squared plus 16, 3 plus h minus 120. So you have 8 squared plus 6h plus 9 plus 48 plus 16h minus 120. And you have 8h squared plus 48h plus 72 plus 48 plus 16h minus 120. So 72 plus 48 is equal to 120. So 120 minus 120, it cancels out. So you're actually left with h squared plus 48 plus 16 is 54h over h, right? Sorry. 48 plus 16 is 64. So you substitute out h, so you're left with 8h plus 64 over h. H is canceled. You're left with 8h plus 64. And when you substitute h as 0, you're left with 64. So the velocity at through instantaneous velocity at position at point distance 3 is equal to 64 meters per second squared. Let's do this. So you have the equation nt equals 20t minus t squared. So the first question is, how many terms are learned between 2 hours and 3 hours? So we need to find, you have to substitute for 2 equals 20 times 2 minus 2 squared, which is 40 minus 4 equals 36. And at 3, you have 20 times 3 minus 3 squared, which is 9, which is 60. So you're left with 51. So you have to find the average between them. So you do average equals 51 minus 36 over 3 minus 2 equals 15 terms. Now the next one is, what is the rate in terms? So this, it gives you one time, so you have to find the instantaneous rate, and which is found by finding the limit. So let's do that. So we know, and they give us a time, which is 2 hours. So you know that at 2 hours is 36. So 20. So at 2 plus h minus 2 plus h squared. So, the question, we're just going to substitute 2 plus h for the t. So 20 bracket 20 plus h minus 2 plus h squared. So here you get a 40 plus 20h minus h squared plus 4h plus 4, 40 plus 20h minus h squared minus 4h plus 4. And remember, we have the minus 36. Sorry. So it's minus h squared minus, this should also be a minus. So the 40s cancel and you're left with minus h squared plus 16h over h. So substitute out the h. Sorry, factor it out. Oh. Then when you substitute 0 into h, you're left with 16. So you get 16 words or terms. Let's go on to the next question. Now it's question 10. A medicine is administered to the patient. The amount of medicine in milligrams is 1 milliliter of the patient's blood. T hours after injection is MT equals negative 1 over 3 t squared plus t. So it's negative 1 over 3 t squared plus t. equals. So it's asking for find the rate of change of amount m after 2 hours. So we have the equation -1 over 3t squared plus t. So we need to find the limit since it only gives us 1 point, which is 2 hours after. So we have the equation -1 over 3t squared plus t. So we need to find the limit since it only gives us 1 point, which is 2 hours after. So we're going to look at -1 over 3t squared plus t. We need to find the limit of this equation. So wherever there is t, we're going to substitute 2 plus h. And since this is a fraction, we want to change the equation to have all whole numbers. So it would be, if we multiply the whole equation, it would be -t squared plus 3t. And then when you put in 2 to this equation, you get -2. So it's going to be t squared plus 3t minus 2. And wherever there is t, we're going to substitute 2 plus x. So you get -h squared minus 4h minus 4 plus 6 plus 3h minus 2. And you are left with -h squared minus h over 3h. Since we multiplied the top by 3, we needed to multiply the bottom by 3. So we had 3h at the bottom. Then we can factor out an h, and you're left with h minus 1 over 3. Then we substitute the 0 into h, and we're left with, we get -1 over 3. And the -1 over 3 indicates that the medicine in the blood is decreasing over time. So let's look at the next equation, which is 11. So for 11, you have t equals square root of s over 5 and t equals 5. So this is s. So square root of 1, you get when t is equal to 5, that's s. You have 125 and 5. The points, t equals s at t equals 5. So anyways, you have square root 125 plus h over 5 minus 5 square root over h. We're going to multiply by the conjugate, which is so you're left with 125 plus h over 5 minus 25 over h bracket square root 125 plus h over 5 plus 5. So you get 125 plus h minus 25 times 5 over 5h square root 125 plus h over 5 plus 5. You get h plus 5. This cancels, and you're left with 1 over 5 square root 125 plus h over 5 plus 5. So when you substitute 0 for h, you get square root of 125 is square root of 125. Oh, sorry, 125 divided by 5. Which is 25. Okay, so square root of 25 is 5. 5 plus 5 is 10. 10 times 5 is 50, so you're left with 1 over 50. Let's go to the next question. 12. You have 60 over h. Sorry, you have the equation 60 h plus 2, and you have to suppose that the temperature T in degrees Celsius varies with height in kilometers above Earth's surface according to equation 60 plus h plus 2. Find the rate of change in temperature with respect to the height of 3. So this, you have to find the instantaneous rate, so by finding the limit. So you have x plus h, so you have the points, you have the 3, so if you put 3 into this equation, you have 3, it's 5, 60 divided by 5 is 12, right? Yep, 3 and 12, so wherever there's h, we're going to do 60, substitute 3 plus h plus 2, which is the same thing as 65 plus h minus 12, and we're going to multiply 5 plus h to the bottom and the top. 5 plus h. So you're left with 60 minus 60 minus 12h over 5 plus h over h. So you're left with negative 12h over 5 plus h, and then divided by it, which is the same thing as 1 over h. So we get rid of this. We are left with negative 12, 5 plus h. So if you substitute 0 for h, you're left with negative 12 over 5, which comes up to negative 2.4. Okay, so now the next question. (13), which is a spaceship approaching touchdown on a distant planet has a height h in meters at time t in seconds given by 25t squared minus 10 minus 100t plus 100. When does the spaceship land on the surface? With what speed does it land? Assuming that with what speed does it land? Assuming that it ascends vertically. So it approaches touchdown. When does the spaceship land on the surface? With what speed does it land? So what we need to do is we need to find the point at which this is 0. And that's when the height is 0, it would have reached touchdown, and the speed would be 0. So let's look at that. Okay, so we know that at touchdown, the speed would be 0. So we need to find this one, 25t squared minus 100t plus 100. So we have to take out the 25, so you're left with t squared minus 4t plus 4. So you have t squared minus 2t minus 2t plus 4. T, you can take out the t minus 2, and then you take out 2. T minus 2. So you have t minus 2 squared and 25. So when it reaches touchdown, t equals 2 seconds. And if you put 2 into this equation, you would get a speed of so we need to find the limit. So 25, you have to plug it in, 2 plus h minus, so when we put 2 into this equation, what do we get? So 2 is 400 minus 200, so it's 0. 100, 2 plus h plus 100. You get minus 200 minus 100h plus 100. 25 h squared 100h plus 100 minus 200 minus 100h plus 100. If we put 2 in this equation, we get 4, which is 100, minus 200 okay, so 25 8 squared plus, so you have, oh, sorry, this shouldn't be 100h, it should be 100. So 100h minus, I have 108, so you're left with minus 100h. Then you have, 100h, 100h minus 200h. You have minus 200h. Well, I wrote this entirely wrong. Minus 100, it's 200, it's just 200. This is I don't know how I got an H. So this 100 plus minus 100 is 0. So 25h, so 100h minus, it's okay, 100 plus 100, so you're just left with, so take out the h, so you're left with 25h for h, so just have 25h. So when you substitute the 0, it's the velocity would be equal to 0. So velocity is 0. The time it touches down is 2 seconds. Okay, so let's do the next one, which is 14. A manufacturer of soccer balls that profits from the sale of X balls per week is given by Px equals 160x minus x squared. Find the profit on the sale of 40 balls per week. So Px equals 40 minus 40 squared, so equals 6,400 minus 1,600 equals 4,800. So that's for question A. B. Find the rate so now we have to do the limit. So for 40 we know that it's, so if we do 60, we know h plus, 40 plus h minus 40 plus h squared minus 4,800. So you have 4,800 plus 160h minus h squared minus 80h plus 1,600, right? 40 squared is 1,600, okay, minus 4,800. Sorry, what is, sorry, it's 6,400. Oops, this one is 6,400 because it's the same as this. So a 6,400, and that's another mistake. This should be minus h squared minus h minus 16. Okay, so you're left with negative h squared minus plus 80h over h. Take out h, you're left with h plus 80 over h. You're left with h, negative h plus 80, and if you substitute h as 0, you have 80. Okay, now 14, now 15. So for question 15, you have the equation negative x squared plus 2x plus 3, and you have negative 2 and negative 5. So we have to have negative 2 plus h squared plus 2 negative 2 plus h plus 3, and since it's a negative number, minus a negative number makes it positive, so it's plus 5. So you have negative h squared minus 4h plus 4 minus 4 plus 2h plus 8. So you have minus h squared plus 4h minus 4 minus 4 plus 2h plus 8. You're left with minus h squared plus 6h over h. You have h, negative h plus 6 over h. You have 8, negative h plus 6. Substitute 0 as h, and you have 6. So B. Do a new screen. B, you have the equation x over x minus 1, and you have the points 2 and 2. So substitute 2 plus h over 2 plus h minus 1, which is equal to 2 plus h over 1 plus 8 minus 2. Then you have to multiply the denominator, this common denominator, to the top and bottom. So you have 2 plus h minus 2 minus 2h over 1 plus h over h. So you're left with negative h over 1 plus h. And if you're going to divide by h, it's the same as multiplying by the reciprocal 1 over h. So this cancels, and you're left with negative 1 over 1 plus h. If h is 0, you're left with negative 1 over 1, which is negative 1. The next question is C. So which is square root of x plus 1, and you have the points 24. So if we put 24, the square root of 24 is 5, so we have these points. So if we have square root a24 so you have square root 25 plus h minus 5. So we should multiply by the reciprocal, which is 25 plus h plus 5 over 25 plus 5 plus 8 plus 5. So you're left with 25 plus h minus 25 over h square root 25 plus h plus 5. You're left with h over h. You're left with square root 25 plus h. Oh, plus 5. So the h is canceled. You're left with 1 over square root 25 plus h plus 5. So it's, if you substitute 0 as h, you get square root of 25, which is 5 plus 5, so it's 1 over 10. So now the next question is 16. Okay. So we need to find the limit of this equation. So, and we have to find the difference between 2005 minus 1982 is 23. So the x point is going to be 23. And if you put 23 into this equation, what do you get? You get $8,566.55. So you're gonna use 23 and 8. These are the points. 566.55. Those are the points. So we have We have 246 plus 64, 23 plus h minus 8.9, 23 plus h squared plus 0.95, 23 plus h cubed minus 8,566,555. So when you actually do this out, you actually are left with at the end 1.162.25h plus 5.562h squared plus 0.95h over h, and you substitute out the h, you're left with 1162.25 plus 55.62h plus 0.95h squared. And when you substitute h as 0, you're left with 1162.25. And you need to multiply this by 1,000 to get its true value, because this isn't a thousandths. So your actual value is 1162250. So that's 16. And for 17, so for 17, you have the equation x equals 3t squared. And let's look at the question. Find the distance traveled from 0 seconds to 5 seconds. Find the rate at which the avalanche is moving from 0 seconds to 10 seconds. Find the rate at which the avalanche is moving at 10 seconds. How long to the nearest second does the leading edge of snow take to move? Okay, so let's do this. Okay, so from 0 to 5. So at 0, x0 is equal to 0. X at 5 is equal to 3. 5 squared is 25, so it's 75. And you do 75 minus 0 over 5 minus 0 equals 75 divided by 5 equals 15. meters per second. Okay, so B, from 0 to, so what is it at 100? X equals 3 at 10. Sorry, what was it? It was from 0 to 10 seconds. So from 10, it's 3 times 100, 3 times 10, 100, so it's 300. So you're going to do 300 minus 0 over 10 minus 0, which is 300 over 10, which is 30 meters per second. Okay, I see. This is where we need to find the limit. So and it's asking for at 10 seconds. So we know it's 300. So 3, and we need to find it at 10. So 10 plus h squared minus 300. 10, yeah. So you have h squared plus 20h plus 100 minus 300. You have 3h squared plus 60h plus 300 minus 300. 3h squared plus 60 over h. Factor out the common h, which is h plus 60. Sorry, that's 3. And if you substitute 0 for h, you're just left with 60. And here it says, how long to the nearest second does the leading edge of snow take to move 600? So you have 600 equals 3t squared. So 600 divided by 3 equals t squared. So t squared equals 200. T equals square root of 2 square root of 100, which is 10 square root 2 seconds, which is roughly around 14 seconds. Let's look at 18. So 18. Sorry. No, 18 is just 18. So 18. So, okay, so we need to find the derivative, we need to find the limit of 1 over x, and we're given that the point x is a. So we have 1. Let a and b both point on any graph y equals 1 over x, x does not equal 0. Prove that the area of the triangle formed by the tangent a and b and the coordinate axis is 2. So we have 1 over x, and the point is if a, so it will be a and 1 over a. So if we have 1, a plus h minus 1 over a, So what we need to do is we need to multiply this by a and this by a plus h. So what it becomes is a over a plus h minus a plus h over a plus h times a equals a minus h over a plus h, a over h. So you're left with negative h, a plus h times 1 over h, which is cancelled. So you have 1 over a plus h. If we substitute h as 0, we are left with negative 1a squared. Okay, so now that you have that, what we do is y equals negative 1a squared x plus b. So now we know that this is 1 over a, and this is equal to negative 1a squared, and this is a plus b. You get 1 over a equals negative 1a plus b equals 2 over a, right, equals b, right? So now we have the equation y equals negative 1a squared x plus 2 over a. So you have the equation y equals negative 1a squared x plus 2 over a. If we want to find the x-intercept, we should substitute y as 0. So 0 equals negative 1a squared x plus 2a, negative 2 over a equals negative 1a squared x, negative 2a squared equals 1ax negative. So negative 2a squared divided by negative 1a equals x. So 2a equals x. So if you do So you have the intercept, which is 2a, and the y-intercept, if you multiply it times 2a divided by 2, which is the same as multiplying by a half, you have 4a over 2a, which is the same thing as 2. So that proves. So let's do 19. Megacorp's total weekly cost to produce X pencils can be written as Cx equals F plus Vx, where F, a constant, represents fixed costs such as rent, utilities, and Vx represents variable costs which depend on the production level of X. Show So we have Cx equals F plus Vx. So Cx plus H equals F plus Vx plus H. Which is equal to Cx plus H minus Cx over H, which is Vx plus H minus Vx over H, which is independent of the fixed amount. Okay, so that's 19. Let's look at 20. So 20 is the area is equal to pi r squared. So since we need to find the limit, so pi r plus h squared minus pi r squared over h equals pi r squared plus 2rh plus squared minus pi r squared over h equals pi r squared plus 2 pi RH plus H squared pi minus pi R squared over H. So this cancels with this, so you're left with 2 pi RH plus H squared pi over H. So you have, when you take out the H, you're left with H 2 pi R plus H squared. For H, they cancel. So you're left with 2 pi R. So it is equal to 2 pi 100, which is equal to 200 pi. It's for 20. For 21, you have V equals A cubed. So A plus H squared cubed minus A cubed. You have A squared plus 2AH plus H squared plus A plus H. You get A cubed plus A squared H plus 2A squared H plus 2AH squared plus AH squared plus H cubed minus A cubed. You're left with A squared H plus 2A squared H plus 2A squared H plus AH squared plus H cubed. So then you get A3A squared H plus 3AH squared plus H cubed over H. You take out 3A squared plus 3AH plus H squared over H. Then you substitute 0 for all of these and you're left with 3A squared, which is equal to half the surface area of the half the surface area of a cube. So if you look at the surface area of a cube, is 6A squared, and half of it divided by 2 is 3A squared, which is what this is equal to. So that's true. So that's fine. Now let's do question 22. In question 22, you have 4 pi r squared. So 4 pi r plus h squared minus 4 pi r squared over h. You get 4 pi r squared plus 2rh plus h squared minus 4 pi r squared. 4 pi r squared plus 8 pi rh plus 4 pi h squared minus 4 pi r squared for h equals 8 pi r h plus 4 pi r squared over h. So h, you're left with 8 pi r plus 4 pi rh. And then you substitute 0 for h, you're left with 8 pi r. And you substitute the radius, 8 pi 10. You get 80 pi. And that's for A. And B. For B, you have 4 over 3 pi cubed. So you have 4 over 3 pi r plus h cubed minus 4 over 3 pi r cubed. 4 over 3 pi bracket r cubed plus r squared h plus 2r squared h plus 2rh squared plus h2r plus h cubed minus 4 over 3 pi r cubed. Get 4 over 3 pi r squared h plus 4 over 3 2r squared h plus 4 over 3 pi 2r squared h squared, no, r h squared plus 4 over 3 pi r h2 plus 4 over 3 pi h cubed. So 12 over 3 pi r squared h plus 12 over 3 pi h squared r plus 4 over 3 pi r h cubed. So that equals to 4 pi r squared, squared h, no, plus 4 pi r h squared plus 4 over 3 pi r h cubed over h. If you factor out h, you're left with 4 pi r squared plus 4 pi r h plus 4 over 3 pi r h squared. For h, the h's cancel. And when you substitute h equals 0, you're left with pi r 4 pi r squared, and the radius is 10. No, the radius is 5. So you have 4 pi 5 squared is equal to 400 pi